Great. Thanks so much for the invitation to present and also the wonderful introduction. So I'm going to talk about a number of natural language processing projects that are in various stages at the Riksbank. Most of it will be my own research, and some of it will be about some public initiatives that we have that anyone here, for instance, is welcome to participate in. So the work that I do mostly, I'm a computational economist, so I do work on solving macro models that are analytically intractable, but I also do work on applied machine learning, specifically to natural language processing. I also teach courses for data camp, so I teach their introductory course on TensorFlow and Python, and I also have a textbook on TensorFlow for economics and finance. So I'm involved in machine learning, doing work in machine learning, and these days I'm also starting to do work on quantum computing, including applications to quantum machine learning. Okay, so I'll talk about first some research projects. I'll start off with a project that's actually complete and which was recently published. Then I'll move on to a project that's in progress where it would be great to get any input, especially on the NLP side from those in the seminar today. And then I'll end with a project that is just being started now, for which I'm looking for co-authors outside of the economics discipline. So that may be something that's interesting to some people here who are in other fields who might have an idea of a good research question that could be asked for the data set that I have. And then I'll end with a discussion of two different initiatives that the Riksbank is involved in related to NLP. Okay, so the first project that I'm going to discuss is a paper that was recently published on business cycle narratives. And I worked on this project with my co-authors, Christoph Birch and Xin Zhang, who are both at the research division. So we do a lot of work on machine learning together, and it's mostly centered around natural language processing and either texts that are related to the business cycle or related to central banking. So the title of this paper is Narrative Fragmentation in the Business Cycle, and it was recently published in Economics Letters, which is an outlet for short papers in economics. Now, the motivation for this paper comes from Robert Shiller's presidential address to the American Economics Association in 2017, in which he calls for a more rigorous treatment of narratives. So specifically, he calls for the establishment of a subfield of economics that he calls narrative economics. And his claim is that if we look at the business cycle and we look at crisis events like financial crises and recessions, we see the fingerprints of narratives all over the place, and yet narratives don't show up in our workhorse models in macroeconomics. Now, part of the reason for this is that in the past, we didn't have a good way of measuring things like narratives. And even if we did, we didn't have the data for it. But thanks to work in the natural language processing field, we now have models that we can use that can extract features from text that tell us something about narratives related to the business cycle. And we also have lots of digitized texts that we can use, from which we can extract those features. So his claim is that we should now make, a serious effort of this. Let's actually try to measure narratives, and let's see what role they actually play in affecting the business cycle. Now, our objective in this paper was a very modest one. We wanted to contribute to the establishment of this field mostly on the measurement side. So there's already some work that's been done here, including work by Stefan Pichner, who's at Uppsala University. So he's another economist. He's doing some of the best work on natural language processing in economics, in my opinion. Now, our objective in this paper, to contribute on the measurement side was specifically to look at fragmentation of narratives. And the reason for this is that, Shiller's hypothesis is that, you have a narrative that gains steam, it becomes prevalent, it becomes convincing, and it becomes strong enough that it coordinates behavior across households. So for instance, if a narrative takes hold that the housing market is going to be stronger in the future than we think that it will be right now. So, the next 5 to 10 years, house prices will grow faster than we expect them to grow right now. Then if I'm thinking about that from the perspective, of an individual who might buy, I'll be more likely to buy because I can capture that house price appreciation. And also I can buy at a lower price if I purchase the home today rather than in the future. So if that narrative is strong enough, then it can coordinate enough behavior across households that it generates what we call an aggregate fluctuation in macroeconomics. So if we aggregate out household behavior in the form of GDP or consumption or investment, we actually see those aggregates move because the narrative is strong enough. Now, the reason why fragmentation is interesting here is that if we have a very fragmented narrative, so we have multiple competing explanations for what's happening with the underlying state of the housing market, then we can't really gain the strength that we need to coordinate household behavior and get an aggregate fluctuation. So that's why we want to measure fragmentation. We want to see how strong narratives are and how that varies over the course of the business cycle. Specifically, the way that we're going to measure that is by looking at entropy over the narrative, and I'll talk about how we measure that specifically later. So we care about the dominance of the narrative. That's what we're trying to get at in this work. So we use a Swedish language corpus for this project, and it's something that we assembled for the project specifically. So we collected data from a Swedish newspaper archive over the period between 1900 and 2019. The reason why we limit it to these dates is we want to look at a period over which we have national accounts data, so we actually can see measurements of the business cycle itself, output, consumption, investment, and so forth. And also because the language that's used to describe business cycles changes a lot over time. So already, in the period before 1950 in this data set, you have some substantial differences in the language that's used to describe a business cycle. And it gets even more different if you go further back than 1900. So in the end, we actually ended up cutting the sample off at 1950 because this is where we get much more uniformity in the description of business cycles. But in principle, and in future work, we could go back and try to look at what was said about business cycles before 1950. And I think that would be interesting, but we thought that was too much NLP for the project, and it got us too far away from the economics question. And so we cut it off at 1950, but this is still, a very long text data set to look at when it comes to business cycle narratives. So specifically, we concentrate on newspaper articles, which make reference to the business cycle. And this gives us a total of about 62,000 passages from newspapers. And these are fairly short passages, so 1 or 2 sentences. Then what we do is we clean the text and we encode it as word embeddings. So we use the pre-trained embeddings for the Swedish language from Fahlgren and co-authors 2016. And then we do some additional fine-tuning on this. So we want to not just have embeddings that understand the Swedish language, but also understand newspaper articles written about business cycles. So I'll say something about the quality of the fine-tuning. And this, of course, is just an example. This isn't, rigorous proof of anything. But after the fine-tuning, we just look at what the embedding space looks like, what words co-locate in the embedding space. And here in this example, what we've done is we've taken the embedding for the word inflation, and then we've identified its nearest neighbors. And then we just plot the embedding space over 2 dimensions for those nearest neighbors. So this isn't showing the whole embedding space. It's just showing a small slice of words that are close to inflation along those 2 dimensions in the embedding space. And we can see that we have words like growth and central bank and Riksbanken and consumer and interest rate and so forth. So it looks like the words that are close to inflation are close to the word inflation when it's being used in an economic context, not when it's being used in its context, in its use in physics or in the sense of inflating a balloon. And so here it looks like the fine-tuning does actually encode in the embeddings information about economics and business cycle narratives specifically. Okay, in terms of the modeling that we do in the paper, we make use of the latest variant of topic model, which is introduced by Bly and co-authors in 2019. So I think we were one of the very first applications of this model. It was maybe a few months after it was released that we started working on this paper. Now, the reason why we adopt this is that we need dynamics. So we're working with narratives that evolve over time, over the business cycle. So we can't just use the static LDA model. We have to account for the fact that there should be persistence in narratives over time. And then also we wanted a way to capture the narrative that went beyond just a simple distribution over the vocabulary, because the vocabulary itself, even though it's mostly uniform over the period we look at, does change still quite a bit. And so what we want is some measure that we can use that can tell us the state of the underlying narrative that captures meaning in some sense. So here we use an embedding. We have a time-varying embedding, which comes out of the model. So the model has both a time-varying topic embedding and also static vocabulary embeddings. We also need a model that's capable of handling a large vocabulary. So, we have over time change in the words that are used to describe business cycle. And so we need a superset of all of the vocabularies that are used throughout our sample period, not just the one that is used at the end or used in the most articles. The other benefit of using the dynamic embedded topic model from Bly is that it's also much more interpretable than other topic models. So it allows us to perform a number of different queries using the embeddings. So let's say we want to know, we want to compare the narrative in the oil market, and oil ends up being one of our topics, for example, in 2 periods of time. Like we want to take the 1970s, which was a turbulent period for the oil market where we had big supply shocks. And we want to compare that to some other period where we also had supply shocks, maybe supply shocks that are happening today. Well, with the Bly model, we can just take the dynamic embedding in those 2 different periods of time and compute the inner product, and that will tell us the strength of the relationship between the narratives in those 2 different periods of time. Another thing that we can do is compare the strength of the relationship between 2 different topics at the same point in time. So for instance, let's say we think that the way in which the house prices are being described or developments in the housing market are being described is increasingly being coupled to lending. Maybe there's a narrative that loose lending is allowing for increased demand for housing, which is pushing up prices. Well, with the Bly model, we can take the topic for lending and we can take the topic for the housing market and we can compute their inner product and look at the time evolution of that inner product in our sample period. So those are some of the benefits of using the Bly model, and we construct some that I think may have been novel at the time. I suspect they've been used in other projects since, but there's a lot of richness to the outputs from that model that can be used to think about narratives in general, or more specifically, business cycle narratives in our context. To give an example of one of the tests that we perform in the model, just to see if the output of the model itself aligns with what we expect as domain experts in economics, we looked at cases where we knew in advance that there should be a narrative in economics. So for instance, we know that with the Million program in the 1960s, which is a big housing construction project in Sweden, there should be a large narrative somewhere in the late 1960s and early 1970s about housing construction. And when we look at the probability that's being placed on the vocabulary term housing construction for our different topics. So this is just showing this for 10 topics, the 10 topics in the model. We see a big spike around that time, which is when we would expect to see sort of the biggest event with respect to housing construction. And we also see this resurface during the period leading up to the Great Recession. And now, of course, there's a lot of talk about housing construction again, and we see it at the end of the sample increasing. So the model produces, the model seems to produce sensible results when we dig into the model outputs and then evaluate it to, relative to what we expect as domain experts. Okay, so I mentioned before that we want to measure fragmentation in narratives so that we know how strong a narrative is. Do we have multiple competing narratives, or do we have a single dominant explanation for what's happening to the underlying state of the economy? And the way in which we do this is by measuring entropy in the narratives. And I probably don't have to explain this at an NLP seminar, but I'll give a very quick overview just so it's clear to everyone. So let's say you have a topic model, and that topic model has 5 topics: inflation, output, debt, investment, and housing. And it produces topic proportion shares, or probabilities that it's placing on each of those topics in each period of time. And it places a uniform distribution over the topics. So it says, looking at the data, it looks as if each of these 5 topics is equally important in the period in which we're looking. Well, this is the case when we have maximum entropy or maximum fragmentation. We don't have a dominant narrative. We have many competing narratives. If instead we have a degenerate distribution where all of the probability is placed on inflation, then that's the minimum entropy case where we have a single dominant narrative. And so this is roughly what we're getting at. Now, there's one thing that I'll add to this, which is that we're not actually looking at entropy across the topics. So we're not using topic proportions. We use them in this example, but in practice, we're actually using within topic entropy. So we're looking at the entropy over the distribution over the vocabulary for a topic, not across topics. Okay, in terms of what the model produces as outputs, we have topic embeddings, which we're going to make use of extensively. So these are dynamic. They have a time dimension. They also have an embedding dimension, and they have a topic dimension. We also have vocabulary embeddings, which are static in this model, so they don't vary over time. And the output that you might expect us to use is topic proportions, but we actually will not make use of that in this paper, and instead we'll focus on the topic embeddings. So I'm not going to say too much about the formal results in the paper because I think it may be more useful to talk about the NLP, but I'll give a visual overview of what it is that we find just so I can move on to other projects and talk about the NLP content of those as well. So here, what we do is we compute within topic entropy, and then we average that within topic entropy across the topics, and we're computing that at each point in time. Then we detrend the entropy to remove the drift in time. We just want to see its cyclical properties. And that's plotted so that average within topic entropy detrended is plotted on the right axis using the solid line with circular markers. And then we plot in the dotted line GDP growth also detrended so that we just look at its cyclical properties. And what emerges is a clear negative linear association between the two. So we won't say anything about causality. We're not going to claim that one is moving the other. Our goal is much more modest. It's just to measure the relationship and then look at the correlation or the linear association, and then later work and look at causality. But here, if we just look at this association, we see a clear negative association. So when entropy is rising, GDP growth tends to be falling relative to trend. And when entropy is falling, GDP growth tends to be rising relative to trend. So a simple story you could use to explain this is that during an expansion, we become increasingly convinced that we have the single explanation for what's happening with the underlying state of the economy. And since things aren't changing very much, bad things like recessions aren't happening, or we increasingly convince ourselves that this is true. And then some bad shocks arrive, like say a financial crisis that originates from abroad, as in the 2007-2009 financial crisis, or say the shock that came from COVID. And then all of a sudden, those tight, neat narratives break up into multiple competing narratives when the recession arrives. And so that's what we think is a plausible explanation for this basic finding. And I won't go further into sort of the empirical work that we do on top of this, but we extract the NLP features, and then we do some econometrics to try to get at this relationship more carefully and also to estimate the size of it. Okay, another thing that we take out of this model is a variable that we construct, which we call memory. And here what we're getting at is the fact that we can look at the relationship between the narratives for a given topic at any two arbitrary points in time by just computing an inner product. So I gave the example before of the oil market and the turbulence in the 1970s. Maybe something happens with the oil market again, and we want to see if the way that it's being described looks like the way that it was described in the 1970s. We just compute an inner product, that's it. So what we do to construct memory is to compute these inner products for all pairs of times in our sample. And then we construct a variable that is the share of past events that have a positive inner product for a given topic. So this is telling us in some sense, when a newspaper is structuring its narrative about the housing market, how many past periods of time does it have that looks similar to the period that we're in today when they're deciding how to structure a narrative? So that's what we're trying to get out of memory. So here we show a heat map, which just shows the positive inner products and their magnitude for all of the cases, for all of the periods of time, and for the policy topic. So this is referring to things like fiscal policy and monetary policy. And here we can see, to just explain how you would interpret this, if you look at the year 2019, and then you look at cases where we have a colored cell like 1993 and 1994, this is telling us that the narrative about policy in 2019 was highly similar to the narrative in 1993 and 1983 and 1984. And then there's another cluster, again, in 1996 through 2003, where we also see a high degree of similarity. And again, we went through these to just see, does this align with what we would expect as domain experts who are familiar with the narratives that prevailed at that point in time, and we're familiar with the economic context in which they prevailed, and it actually seems to do a pretty good job of capturing this. Now I'll skip the empirical results so that I have more time for the next paper, but I'll just summarize what it is that we found in this paper. So the first is that narratives tend to consolidate during expansions and fragment during contractions. And the basic story that we tell behind this is that, during an expansion, the narrative tightens up. We think that we understand what's going on with the housing market. We think that we understand what's happening with unemployment. As long as GDP is growing, as long as we're in the part of the business cycle where GDP is growing. And then as soon as some shocks come that change this, that contract GDP, all of a sudden we don't quite know what's going on. And so we're struggling to find a narrative that explains it. And so if we look at what happens to the distribution over the vocabulary for a given topic, it widens. We start to suddenly place probability on terms that we previously weren't being discussed earlier because we no longer have a strong sense of what's going on. Okay, the last thing that I'll say is just to summarize how it was that we actually used memory, this memory variable. Specifically, what we looked at was its relationship to entropy. So we wanted to see if there were a lot of past reference events that we can make use of, like say a lot of financial crises for the financial crisis topic. When a financial crisis happens today, do we have a narrative that consolidates faster or slower as a result of that? And what we found is that there was much faster consolidation in narratives when there were past reference events to draw from, which is intuitive in some sense. So for instance, when COVID happens, one of the first things that reporters will think about doing is looking back at past pandemics to try to figure out what it is that we might expect. How might public health officials might work? How might public officials, implement restrictions? How might public institutions respond? What might be the effect on health and mortality and so forth? And so they go back and look at the Spanish flu and other reference events. And so if you have a lot of these, then you might say, okay, the only thing we have is, we have the Spanish flu. So let's think about this in terms of the Spanish flu. And so you structure your narrative in that way. But if you don't have anything at all for reference material, then you have to come up with something new. And so you have much more fragmentation in the narrative as we struggle to figure out what's going on. Now, this could be a positive or negative thing. It could be positive in the sense that it makes us think harder about the event itself, or it could be negative in the sense that we don't have this past information to draw from in trying to figure out what's going on with the world. Okay, so I'll move on to the second paper, and this one is very much a work in progress. It doesn't have a title, so we have a bunch of results, but we don't have our final results. And roughly what we're trying to discern in this paper is, what is the impact of academic debates about central banking on the practice of central banking? So there's a lot of literature that's discussing what it is that central banks should do. You have a literature that's asking, that argues in favor of central bank independence in the short run from the government. So central banks say shouldn't face political pressure, because if they do, then you'll end up with the government leaning on the central bank to say, pursue, to stimulate the economy before an election. So, that's one argument that you have in the academic literature. And you have a number of ones that we identified, but there's an open question of how much do these academic debates actually influence the practice of central banks? So they influence, the mandate that the central bank is giving. Did they influence what central bankers think and do? And so this is roughly what we're trying to get at in this paper. Now, the prevailing view, in the academic community is that it has had a positive effect on central banking, and good ideas have ended up resulting in reforms that improved how central banks conduct policy. But you also have some dissenting views. So there's an essay from Greg Mankiw, who's a macroeconomist at Harvard. And the essay is basically about the dual role that macroeconomists play. They're both engineers in the sense that they work at central banks and they have to figure out how to construct solutions to problems. And then they're also scientists. So you have macroeconomics and macroeconomists in academia who are just thinking about how the macroeconomy works and are trying to figure out what is true about the macroeconomy and not trying to think about how to engineer solutions to problems. And so in this essay, one of the things that he looks at is the engineering side and says, is it using the best science? Is it using what it is that the scientist macroeconomists are finding to inform how policy should be conducted? And his conclusion is that it's not. So he says, if you look at what people on central banks, how they think about economics, especially those in senior leadership, it's almost as if it's straight out of the 1970s. So it's not making use of the most recent advances. And you have, some similar dissenting views that go even further and really argue that, even the macroeconomics literature doesn't even do a good enough job of providing, policymakers with the theory that they would need to inform decision making. So that's what we're trying to get at in this paper, is to try to contribute to this debate by making use of NLP to try to discern what it is that central bankers are saying and to determine whether it's actually informed by the latest social science in that area. So we identified 4 different debates which appear to be durable debates in the sense that they've lasted decades. And have had important landmark papers that seem to have made progress in convincing people one direction or the other. So my co-author, Christoph, is digging through the historical material here to figure out what exactly the debates were. The one that we're going to focus on in this presentation is the debate on rules versus discretion in monetary policy. Now, when central banks conduct monetary policy, if we abstract away from things that have happened very recently that involve unconventional policy, mostly what they're doing is just adjusting the short-term interest rate. So it's interest rates on loans between banks in the overnight lending market. And so, an open question is, does that need to be done by a central bank with lots of economists and a research division? And, with people like us working on this stuff, or could you just write down, could you just have a computer execute a mechanical rule that says, when inflation is high, when inflation is high, then you increase the, the interest rate by this much. And if, GDP growth is below average, then you decrease the interest rate and so forth. And in fact, we have work that shows, this is roughly what some central banks appear to be doing anyway. And so it's an open question of, do you need to have, a central bank with staff making these decisions, or could you just have a mechanical rule that's implementing policy itself without that? And there are benefits to having the rule. There's much more transparency. So everyone knows what the rule is. They know how the interest rate is going to change, once, the latest inflation numbers have been released. But there are also drawbacks. So with, allowing policymakers to have discretion, they can also act faster. So for instance, during the COVID outbreak, we knew pretty quickly that GDP was going to contract by a lot, but it takes a quarter for GDP to be measured. And so if you're just using this rules-based measure, you've got to wait for the numbers to come in before you actually, reduce the interest rate. So discretion, on the other hand, has the advantage of the policymakers having lots of additional knowledge that isn't embedded in the system, that they can make use of to do faster decision making. Okay, I won't say too much about the economics, but that's the debate that we're going to focus on: is should we have a rule, in the strictest sense, like Bitcoin, where there's just a protocol that determines, how monetary policy is conducted, or should policymakers have the discretion to change policy as they see fit? Now, the data set that we use in this is actually from the Federal Reserve System, which is the central bank in the U.S. And what we do is we collect speeches given by Federal Reserve officials since 1914. So this was when the Fed was established. And this covers 5,742 speeches for 12 district banks. So the system consists of district banks and also a federal entity that has presidential appointments on it. So this is the Board of Governors. And then they're combined, where you have 5 rotating district bank presidents and 7 members of the Board of Governors that form the policy-making committee that set interest rates. So we have speeches from both of them. Now, the frequency of speeches increases over our sample, and coverage is somewhat unclear. So this is really the first attempt to get all of them, so we're not entirely sure how much of the sample we capture. We also make use of auxiliary data sets and also the landmark journal articles that we talked about. So we want to find articles that shaped the academic debate and see whether they also have an influence on how it was that central bankers were talking about the rules versus discretion debate. Now, the auxiliary data set is about 30,000 economics journal articles that are taken from the S2ORC data set. And then, the landmark journal articles, that's just a small set of articles that were influential. Now, our objective on the NLP side is to measure text features that are closely related to these debates. So we'd like to be able to measure stuff that will tell us about the positions that different districts hold. And we also want to try to measure the types of things that will impede or enhance adoption of new ideas or positions in the debate. So we also want to try to capture whether institutions themselves are actually open to the debate itself, or whether they're closed to it in some sense. So those will be the types of text features that we're trying to capture for the NLP side of this project. On the method side, we're going to, in part of the paper, make use of a pre-trained Roberta model that's fine-tuned to do different tasks. So we use one version that's able to do zero-shot classification. Can we zero-shot classify, interest rate rules and interest rate? Can we zero-shot classify rules and discretion separately? Is that something we can do without training a model, just using pre-trained Roberta model? Then we also look at a model that's fine-tuned to do extractive question answering, and is fine-tuned on the Stanford question answering data set. So there, we're going to see that we can't quite get what we want with zero-shot classification. And so one approach that we could use is to try to cut out pieces of the text by asking a question that narrows down the piece of text that we get, and then trying to zero-shot classify that. So if we could do everything, with just the methods in the first set of methods here, we could do everything with zero-shot classification. But that turns out to be pretty hard for the question that we're trying to answer. So another approach that we take is to do some extended pre-training and fine-tuning of a Roberta sentence transformer. So what we first try to do is to localize the model to understand academic economics text. So we do that using the S2RC auxiliary data set. And then we go further to try to get it to understand understand how to measure semantic textual similarity in that context. And the reason that we use sentence transformer is so that we can perform efficient pairwise comparisons of text sequences. So we have lots of text sequences in the speeches and in the landmark articles, and we want to see how similar they are to each other. So we want to do this in a way that's computationally efficient. And so sentence transformers here are going to be the better choice over using, say, Roberta that's fine-tuned for STS. Okay, so I'll start off by talking about what we did with zero-shot classification. So the first task that we performed was just a dummy classification task. So we just want to see how well does Roberta actually understand what's in these central bank speeches. Does it do a good enough job of performing a trivial zero-shot classification test in the sense that we have exhaustive classes, and the classes capture in a very simple sense what would be in a central bank speech. So here, this is just showing a sequence that's taken from one of the district bank president's speeches. And then we classify it using the classes financial stability, output inflation, and labor market, which is going to capture most of the things that central bankers could be talking about. And we know from looking at the passage that it's mostly about financial stability and a little bit about output. And the Roberta model pretty much gets that correct. So we look at a bunch of examples of this to see how well it looked like Roberta was able to classify zero-shot texts with this type of content. Then what we did is, just went ahead and classified all of the sequences in the text, and then just averaged the class probabilities at each point in time. So we get a nice time series. And again, this does a pretty good job of capturing the things that were actually happening. So for instance, in the 1960s and 70s, you have this big run-up of inflation, which then declines in the 1980s. And this is captured perfectly, essentially, by just doing zero-shot classification on these texts. One thing that's interesting that we can also capture as a text feature, although this isn't so much of a test of the model, is that we also have district variation in addition to time variation. So we can actually capture something about the state of the debate that's going on internally in the central bank by measuring disagreement over the probabilities that are being placed on classes at a point in time. So we can just take, say, the standard deviation for the financial stability class across the central banks, and this will tell us something about how much they disagree with each other. Okay, another thing that we did is we just opened up the Roberta model and looked under the hood to see how well it was doing. So here we're looking at how well the attention mechanism is working. So when we're looking at the word banks, what is it that we're attending to in this sequence that's taken from the speech? It's the same sequence that I showed earlier about financial stability. Well, when the model looks at banks, it attends to the words commercial, function, backup, liquid, financial institutions, and markets. So it looks like the Roberta model, without any extended pre-training on central bank tasks, on central bank text, has a pretty good idea of what a commercial bank is, in the sense that it's attending to the right things. Now, that's, of course, a lot harder when you move to looking at something like rules versus discretion, because on the corpus that the corpuses that Roberta is pre-trained on, things like rules and discretion mostly mean other things. So that's going to be a harder problem to solve. But at least when it comes to a lot of basic concepts in economics that will show up in central bank speeches, it looks to be attending to the right things. It seems to have some sense of what a commercial bank is. Okay, a little bit more on this zero-shot classification exercise. So what we tried doing is taking a naive approach and just going ahead and trying to classify by rules and discretion to see what that got us. And we knew in advance this isn't really going to work. So one of the problems that we encounter immediately is that this is a debate. So those two words are almost always mentioned together. You don't have speeches that are just about rules. They're saying rules are better than discretion. So rules both show up at the same time. So if you construct a time series, it looks the same for rules and for discretion. Part of the reason for this is that we don't make any distinguish between valence or sentiment. So we're not saying rules are good or discretion is bad. We're just saying rules and discretion are two classes. Another issue is that this doesn't distinguish between texts that are relevant and ones that are not. So if a text is irrelevant, we might get equal probabilities for the two classes. Or alternatively, if the speech is balanced, we may get equal probabilities for the two classes. So we want to distinguish between those two cases. So a couple of refinements that we did. First is we added a number of neutral classes, like things like unemployment and output and so forth, to just absorb all of the irrelevant material so that it didn't show up in a rule or discretion classification. Then we also make use of the fact that we can include detailed descriptions as our classifications, because we can include input sequences that are 512 tokens in length. So that's another way to try to get at, in a much better sense, what rule means and what discretion means in the context of central bank speeches. The other thing is that we need to capture the fact that we don't just care about whether rule or discretion is mentioned, but the actual position that's being taken. So there are two ways that we got at this. One way is to just do a separate zero-shot classification for sentiment. And another way in which we can do this is to actually build that into the classifications themselves, like rules are good and discretion is bad and so forth. So there we see a pretty substantial improvement. You know, for time reasons, I won't go into what exactly it is that we find, and I'll talk about the other pieces of the other things that we're doing. So the next thing that we try to do is try to use extractive question answering to give us another way to get at this problem. So let's say the Roberta model doesn't quite understand what rules and discretion mean in this context, but it does a very good job of cutting out the right piece of the sentence when you ask a question. So it extracts a right piece of, the right piece of the sentence. Maybe it doesn't fully understand the content of the thing that it's cut out. Well, we can still use that to try to get at whether rules or discretion is being used in the text. And then from there, we can do a separate classification exercise on what's being pulled out. So that's another approach, another refinement that we take in this paper that seems to be fruitful. Okay, the last thing that we do in this paper is make use of sentence transformers. So the Roberta model itself can be fine-tuned to perform to evaluate semantic textual similarity. But in order to do this, you have to pass a pair of sequences to the model at the same point in time. So you basically have to do the inference task, which is computationally expensive for every single comparison. Now, an alternative to this is to use a sentence transformer, which will produce contextualized sentence embeddings for each sequence that you pass into it. And then once you have the contextualized sentence embedding, to just compare those using cosine similarity. So you just do inference on each sequence one time instead of doing it for every pair of sequences. And then, cosine similarity is computationally trivial to compute. So we use a sentence transformer, which is trained using Siamese and triplet networks. And then we do the comparison of the sequences in the speeches with the sequences in landmark journal articles to see if we're moving towards the rules articles or moving towards the discretion articles. That's our objective in this exercise. Now, to try to improve the Roberta model's understanding of economics text, we do two additional things. So first, we do extended pre-training using a transformer-based sequentially denoised autoencoder. So this is just a dummy, unsupervised learning task that forces the model to understand economics, which it otherwise would not want to do. So what we do is take the sequence of embeddings that are passed to the model, inject noise into them, and then pass them through an autoencoder that's just trained to recover the original embeddings without noise injected into them. So this just forces it to learn something about academic economics. Then we do further refinement to try to get the model to understand semantic textual similarity better by performing fine-tuning. So we take the S2RC abstracts, and then what we do is create a group that consists of similar sequences, pairs of similar sequences. So these will just be sentences drawn from the same abstract. And then we'll create a dissimilar group, which has pairs that are drawn from different abstracts. We train on the STS task, and then this produces sentence embeddings that can be compared to each other using cosine similarity. Now, I'm not going to say anything about the results on that yet because that's still in progress, but that is the approach that we're taking, and it seems to be fruitful in the sense that we're getting somewhere and being able to compare these landmark journal articles about the debate with the things that central banks are saying, and we're able to get something that looks sensible out of that. Instead, I'll just talk about some descriptive work that we do from the output of the model. So this is sort of the first step, is just looking at, what do these sentence embeddings look like? Are they sensible? And so here what we do is we take the sequence embeddings from the paper, we average them up to the document level, so we have one for each speech. And then what we use is a t-distributed stochastic neighbor embedding to visualize them in 2 dimensions. And here we can see some very natural clusters emerge, which we thought was pretty interesting in terms of thinking about the different parts of the debate that are going on at the central bank. So for instance, here the colors represent the different Federal Reserve districts and also the Board of Governors. And so this blue cluster that's spatially separated from the rest is the New York Fed. So the New York Fed seems to have its own separate concerns as embodied by speeches that are very different than what the rest of the Federal Reserve System talks about. And then you have, centrally located districts like, say, the Atlanta Fed, which is really overlapping a lot with the content of a lot of speeches. Another way in which we can look at this is just a heat map that gives us the, that's just for the average cosine similarity between speeches given by 2 different central banks. And again, we can see by the same measure, the New York Fed here is mostly blue, so it's mostly different from the other central banks. Then we also construct features that tell us something about openness to debate, focus on the present versus the past. And I think that I'll skip this in the interest of time so that I can get to the last couple of things that I wanted to discuss after the research part. Okay, so I'll just say something about preliminary conclusions in the paper. The paper's not finished, but one of the things that we find is that the intention mechanism in a pre-trained Roberta model seems to correctly interpret the context in central bank speeches. So it's attending to the right stuff. That was our evaluation as domain experts, looking at, whether, does the model understand what bank means? Does it understand what monetary policy means? And it looks like for many concepts it does. For the concepts we're looking at specifically, not quite. And so it may be possible to do the task that we're attempting to do in this paper, the NLP part of it, entirely zero shot without training a model. But it looks like, there are a lot of challenges. You're going to need to use, you're going to need to make use of a number of things in order to be able to do this fully zero shot. And then we find that using sentence transformers seems to be a promising alternative approach because it allows for efficient comparisons. Okay, so that was, I'll stop there with that project, and then I'm going to just briefly say something in one slide about a new project that I'm starting now, which is about pandemic narratives. So I've put together a corpus of narratives about pandemics, and this is a Swedish language corpus that spans the period between 1800 and the present, so this can be indefinitely updated. I now actually just updated it to cover 2021. It includes COVID. And so this is 18 different infectious diseases every time they're referenced in 979 newspapers, and it's a total of 800,000 passages. So I'm planning to do work with co-authors on projects in economics, but I think that this data set also has a lot of value for other fields like public health and epidemiology. So if there's someone who has a clear research question to ask here and would like to work together on this project, just send me an email. It doesn't have to be, a formal proposal or anything like that. It's just that you have a research question and you know where we're going with it in terms of the publication side. And I'm happy to accept your domain expertise as is and just contribute on the the NLP side and with the data set itself. Okay, finally, I'll talk briefly about 2 external initiatives that the Riksbank is involved in. So the first one is the Applied Machine Learning Economics and Data Science Seminar, AMLEDS, and you can see a link to it below. The Riksbank is one of the co-organizers of this through my colleague and co-author Xin Zhang. So he's involved in the on the organizational side. And so if you have an interest in topics in economics and finance and public policy, and how they're being explored in machine learning, specifically, there's a lot of work here that's about NLP specifically, that I would strongly recommend that you take a look at the AMLED seminar. Okay, the very last project that I'll talk about is the real-time indicators project at the Riksbank. When COVID happened, it became very clear that official statistics weren't going to be sufficient for describing the underlying state of the economy. So, GDP is measured quarterly, inflation is measured monthly. And so, with a pandemic that's unfolding, exponentially on a daily basis, we really need higher frequency data to be able to say something meaningful about the underlying state of the economy. So internally, we started an initiative to do higher frequency monitoring. And then we also developed an external platform that allowed participants in academia and the private sector to contribute projects. So I can see actually today we have some of the contributors to the project here. So Price Runner was one of the first to submit a project. And so what they did is took all of the data from their price databases and on a daily basis construct price and volume indices and push them to our platform. We also have contributions from Moduli, which does machine learning. So what they're doing is collecting all of the Nordic NASDAQ exchange press releases in real time. They're extracting text features, and then they push this to our site. And we also had a wonderful contribution from Pelterion, which was our very first real-time contribution to it, in the sense that every time you refresh the chart, it submits a query and you get the latest data from their model. And so that harvested social media data, extracted text features, and pushes them to our site in real time. And so this project is open to the general public. Anyone who wants to contribute at whatever frequency can send me an email. I'll make an account for you, and you can put up any project that you think would be helpful for the purpose of either tracking COVID or tracking its effect on the economy in real time. Okay, and I'll stop there with the presentation part. Thank you again for the invitation to present.